The commencement has started. NASA has declared that the 350-meter space rock Apophis will head toward Earth in 5 years. Specialists are currently working flat out to plan for this rendezvous with the shot from space. But what can we actually do in the case of a crash? Would we be unprotected against the death and destruction that a space rock of this size would unleash, or are there available means of warding off the danger from space? Well, that is precisely what NASA staff are asking themselves, which is why they recently drew up the emergency plan to deal with a space rock that has a 72% chance of hitting us. It was on June 19, 2004, when Apophis was added to the list of large asteroids. At that time, astronomers Roy Tucker, David Thalin, and Fabrizio Bernardi at the Kidd Peak National Observatory succeeded in adding an S-type space rock, with a width of 350 meters, to the star charts. The object in question consists mainly of silica-containing rock, as well as iron and nickel. Yet, it was, and isn't, the material composition that is still making headlines today. In fact, the primary observations had already shown that the space rock would come extremely close to Earth on April 13, 2029. Therefore, its discoverers decided to give the orbiting body a fitting name, Apophis. The object is thus the namesake of the ancient Egyptian god Apophis, who embodies chaos, darkness, and confusion in mythology. An ominous sign. Well, who knows, but it's certain that Apophis would live up to this disastrous name with flying colors in the event of an impact. The specialists confirmed that the space rock would release an energy of 900 megatons of TNT upon collision. To put this in context, the largest nuclear explosion caused by humans, the explosion of the Tsar bomb, had a yield of 50 megatons of TNT. In this class, what consequences the impact of Apophis would have for life on Earth depends on several overriding factors, first and foremost the specific composition of the space rock and the location and angle of the impact. If the space rock crashes into land, it would likely create a death zone around itself with a radius of 250 kilometers. Beyond this, however, the chances of survival would be relatively high. In the case of an impact in the water, nearby coastal inhabitants would need to prepare for fully fledged monster tsunamis, rising more than 100 meters into the air. But could Apophis become a doomsday asteroid 2.0? In other words, could the space rock's impact trigger a mass extinction of unheard of proportions, just like 66 million years ago? Well, fortunately, the specialists are giving the all-clear in this regard. In order to cause global destruction, the impact energy of Apophis would need to be 1,000 times greater than currently expected. How serious is the danger? In December 2004, the likelihood of an impact was put at 1 in 37, or 2.7%. However, due to further data analysis, an impact with the space rock in 2029 is now considered ruled out. But we must not forget one thing. Apophis will come into close contact with Earth not once, but several times over the next few decades. Because while the object orbits the Sun in a neat 323 days, it will also come especially near to our blue home planet in 2036 and 2068. In an astronomical context, especially near, means around 31,000 kilometers. So, during the next rendezvous, Apophis will pass just below the geostationary satellite orbit, making it visible even to the naked eye. Because of this, some astronomers speculated that the close passage could alter the space rock's trajectory and pave the way for an impact in April 2036. A few more precise orbital calculations and measurements later, however, the specialists announced that there would be no imminent danger from Apophis in this century. But then, the Yarkovsky effect came into play, and the real risk of a crash was suddenly on everyone's lips again. In March 2021, the team led by David Thalin, who, as mentioned, was one of the discoverers of the space rock, identified a series of decisive changes that reignited concern. Observed with the Subaru telescope on Mauna Kea in Hawaii, the researchers realized that Apophis was no longer where they expected it to be. In detail, the new studies showed that the object was drifting away from a purely gravitational orbit by about 170 meters each year. This orbital shift significantly increased the risk of impact for the year 2068, and the cause was thought to be solar radiation. According to this, the Yarkovsky effect occurs because the sides of the space rock heat up to different degrees depending on the speed and direction of its own rotation. This causes it to be deflected slightly inwards or outwards by the radiation pressure. However, NASA declared a few months later that based on new observation data, there is no risk of an Apophis impact for the year 2068. The flip side of the space rock coin, while the public's interest in Apophis generally revolves around the catastrophic scenario it could possibly evoke, we quickly forget that the space rock also offers scientists a unique research opportunity. The approach of the object also offers astronomers the chance to gain new insights into such near-Earth asteroids. In fact, a near-Earth visit by an object of this size only happens once every 1,000 years on average. To give the cosmic visitor a proper welcome, a team from the University of Freiburg is currently working on 3 different concepts for missions with small satellites that will explore Apophis. The NOLY mission could serve to break some fundamental asteroid puzzles. These concern their structure, the impact of their trajectory, the gravitational interaction with other objects, and above all, the question of how to prevent an impact. To draw one step closer to finding the answers, the Freiburg research team, led by Professor Hakan Thiel, is toying with the idea of developing a small satellite that would observe Apophis for several days on its way to its closest point to Earth and accompany it for a few weeks afterward. In this way, changes in the space rock could be captured directly on camera and supplemented by detailed measurements. However, such an endeavor would also be a mammoth technical task. The alternative concept goes by the name of Ramses. As part of this mission, a larger satellite, equipped with small satellite telescopes and other measuring instruments, sets out to reach Apophis. The small but crucial catch here, however, is the fact that the actual execution of the Ramses mission is still, as they say, written in the stars. The third approach is ultimately based on the launch of a single small satellite, much like the first, but this time it merely flies by the space rock object of desire once and records it visually at its closest point to Earth. The cost of this mission would be relatively low, but the same would probably also apply to the data acquired. In the end, it is a matter of weighing up which option makes the most sense and is most likely to be implemented. The specialists are expected to announce their decision next. As mentioned, we will be spared an asteroid impact in the next 100 years. But what about the worrying headlines that have been circulating on the internet for a few weeks now? These read, for instance, probability of asteroid impact in 2038 at 72%, or asteroid will hit Earth on July 12, 2038. So, how should we classify these ominous headlines? Has the moment of panic finally arrived? Well, it is undisputed that the horror scenario announced is, at least in part, based on an official NASA announcement. But it's also undisputed that it's merely a hypothetical simulation game designed to help specialists better prepare for an emergency. Not just recently either, NASA has, in fact, been holding its asteroid emergency drills every 2 years since 2016. This time, the NASA JPL Center for Near-Earth Object Studies simulated the scenario of an asteroid several hundred meters in size that would collide with Earth in 14 years with a probability of 72%. Densely populated areas in North America, Southern Europe, or North Africa would be at the center of the danger. And to make matters worse, the hypothetical chunk would travel too close to the Sun for a long time, making it difficult to detect. Against this background, it was up to the 100 participants to develop strategies for asteroid defense, public relations, and disaster preparedness. Ultimately, however, the main conclusion was that we are currently not particularly well prepared for the worst-case scenario. One fundamental issue, for instance, is that the handling of such a situation is completely unclear. Neither in the USA nor in the rest of the world are the procedures in the event of an asteroid impact clearly defined. Although there is an unofficial planning commission, the Space Mission Planning and Advisory Group, the participants in the exercise didn't have the foggiest idea which role this, in fact, plays. There was also the difficulty that, to say the least, was challenging to maintain. The efforts for asteroid defense over a period of 14 years, in particular, political administration changes, budget shifts, and the diverting effects of world events, caused confusion. However, despite the multitude of shortcomings and gaps that were revealed, NASA drew a positive conclusion. It said in a summary that the exercise raised awareness of the nature of the asteroid threat and the challenges with establishing an effective global response. Among the final recommendations were to better communicate the role of SMAG, lead more exercises, and design message templates for the population in the event of a real threat. It should indeed be possible to assess the risk of potentially hazardous celestial bodies even better in the future. NASA plans to launch the Near-Earth Object Surveyor, a space telescope that will look for new near-Earth asteroids by the summer of 2028. And your search for the Near-Earth subscription button should be completed immediately. Press like and subscribe now to never miss an amazing video from us again.